Okay, we just released our first tutorial series on how to actually port this real-time project to the Oculus Quest. And there's a lot of optimization tips and tricks I'm going to share with you here. But the most common question is how we actually get the outline effect to work on the Oculus Quest. Because the most common workflow for this is to use post-processing. But the post-processing is very expensive because you need actually custom dev, you need this material, and you need to have mobile HDR enabled. And this is actually very expensive for the Oculus Quest. Most of the people actually trying to get this to work are running with very, very low FPS or get black screens. So we came up with a different approach. And of course, you can just use our framework with the implemented functionality. But I also wanted to show you how you can create it for your own projects. And this is just a basic implementation, but there are a lot of things you can improve there to get the outline effect actually work with your Oculus Quest project. Okay, for this tutorial I decided that it would make the most sense if I start with a template project, so every one of you can just follow along. It's not the best starting point, but it has some features in there we can actually use. So I keep everything at the default settings here, but I want to have some of the starter content to actually show you later how this effect works on different meshes. And let's create a name. And there are two basic maps in there, in this template. The one that is actually working with the Quest, you will find it in here. Let's go into the map folder, and we want to open the motion controller map, not the HMD locomotion. So let's open the motion controller map. And this is the default map that is actually working with the Quest. So if I would start this now, you can see I have just a basic implementation of teleporter. You can see I have my hand, and if I press the button, I can teleport. So nothing fancy in there. So what we will do in this tutorial is to actually create a component we can add to any blueprint or static mesh, and it will completely handle all of the highlight functionalities. We will also make some basic settings you can change. So let's dive right in. First of all, I'm going to explain you what we are actually trying to create. So let's start with a new folder and let's name it Outline Effect. So what we are going to do is we want to have, for example, this mesh here, and we want to have a nice outline around it. The way we will achieve this is actually, let's copy the location. We want something to trigger this actor, and then we want to duplicate the static mesh itself, scale it a little bit bigger, and invert the normals that we can only see the backside. So I'm going to create the shader first so you can actually see what the final result will be. And open it up. There are different ways we can achieve this. One of them, let's set the shading model to unlit and first create a color. And because we want to change this parameter later on, let's convert it, name it color, and plug it into our emissive color. So the way I'm going to set this up is I want to use a two-sided material for this. And let's use the nose two-sided sign. Let's set the blend mode to translucent. And actually, I don't want to see the front side, I only want to see the back side of the mesh. So let's invert this and plug it into our opacity. This way we will only see the backside of our mesh. And the last thing we want to do is to inflate this mesh just a little bit. So we want to have the vertex normals. And we want to multiply this value by a new parameter. And this will be the actual thickness of the outline. So let's name it thickness, give it a default value of maybe 1. And put it into the world position offset. And the higher this value is, the bigger our outline will be. So let's hit apply. And I'm going to create a material instance to show you in real time what this is actually doing. So let's apply it to our mesh. Actually, I scaled this one, so I'm going to remove it. I duplicate it again and assign a new material. And now you can see we can only see the backside of this mesh. And if we place them on the exact same position, you can see that we already have a small outline effect. And if I open up the material, the first parameter, of course, if we change the color of the outline effect will be changed. And if we change the thickness, you can actually change the outline effect thickness. The component we are going to create should do all of these steps we just did by hand. So let's start. I'm going to create another sphere here. And we want to test it with this sphere. The way you are going to create a component is you select the blueprint class, but not an actor. In this case, we want to have an actor component. And I'm going to show you what an actor component basically is. So let's create it and name it highlight component. And a component, you can actually add a component to every actor in your scene. It could be a blueprint, but it could also be just any actor here. The way you added this to the actor is you press here the add component button, and let's select our highlight component. And here you can see we have just added this component to our actor, and we can also go in there and add it to this actor. So both of them now have the highlight functionality. Of course, right now this is not doing much, but let's go in there and start to give this some logic. It's very similar to the event graph you are already familiar with. So we don't need a tick function here, but for the beginning we want to keep the begin play. So what we are trying to do is we want to get the owner. So the actor that is actually owning this component here. And we want to get its components by class. So basically what we are trying to do here is we want to get the owner of this component, and then we want to see if this actor basically has a static mesh. So let's search for the static mesh component. And if he has a static mesh, we want to spawn a new actor. So you remember we have this sphere, and what we did is we duplicated it. So basically we're doing the same thing here. We want to create a new actor, so spawn actor from class. And we want to spawn a static mesh actor. And we want to spawn it at the exact same position this mesh here is. So let's get its world transform. And set it in there. So in our case, we found our sphere it is a static mesh. So we get the transform of the mesh and we spawn a new static mesh actor. If you spawn a static mesh actor, it actually has no static mesh yet. It's just empty. So we want to set its static mesh. For the new mesh, we want to have the exact same mesh that we found on the actual actor. So let's get the static mesh component. Get static mesh and set it in there. So what this is doing, it's actually duplicating the static mesh we have here, spawns a new actor and then sets the new mesh. So we should have a duplicate of the sphere in our case. And for this sphere, we want to set the material. And the material will be our highlight we just created. The name was outline master. Or we can also use the instance here. So let's type in outline. And hit compile. And basically this should already work. So if we hit play now, for both of them, you should see that, let's hit simulate, and you can see it was spawned, also for the cube here, and they both have this outline effect. So this is already working. We may need to add some things in here later on, but first of all, let's start implementing some functionality when this is actually being triggered, because right now at the begin play is nothing really useful for us. So let's disconnect this, and we want to create a new custom event for this. Let's call it on highlight. And for a quick test, let's print a string that says, I'm working, and hit compile. So we want to call this event here. And actually this map has already some basic functionality. As you remember, we had this teleport beam. For the purpose of this tutorial, I'm just going to add this logic into the teleport beam. So let's open it up. It should be in here. And the one for the quest is actually this motion controller in here. We want to find the teleport arc where it is created. And it should be in here, trace teleport destination. This is the actual place where the teleport beam is created. Right here. And it has this hit result, and into this hit result we have some information we want to use. For example, we have the hit actor. So first of all, once I create this projectile, I want to see if it actually hits an actor. So let's see if it's valid. And if it's not valid, I can just continue with the logic. But if it's valid, I want to see if this actor actually has our component we just created. So it was our highlight component. Let's also see if this is valid. And same thing here, if it's not valid, it's just a basic actor. So we can continue with our tracing. But if it's valid, we want to trigger the event we just created, so the on highlight event. And after we have triggered that, we can continue here. So just to recap, here is the actual prediction of the projectile, and if it hits something, we want to see if this is an actor, and if it is an actor, we want to see if it has the component highlight we created, and if so, we want to trigger the onHighlight event. Right now it's just printing the string, so we can try to play it in VR, and you should see I can completely teleport, but once I hover over the sphere, you can see I'm working. So this is working. Also the same should be true for this cube here, nothing here, and it's triggering. So our component is now talking with the laser the way we want it to, and now we can implement our functionality. So let's connect it this way. And since we are spawning this mesh at runtime, we need to fix some things, because right now if you're going to play, we will get an error. So I can quickly show you, nothing is happening here. And if we close the editor, you can see we have errors, and they say we wanted to actually move a static mesh. So we would need to set its movability. Its mobility to movable. Set it this way and try this out. And now we should already see the outline effect, so no outline, and if I hover over it, you can see the outline is there. But you can also see it's not disappearing, so it's staying there all the time. And a way to fix this is to actually set the lifespan of this newly created outline actor here to something very low. So in Unreal, every actor has a lifespan. Basically, this determines how long this actor is going to live. And if it's set to 0, it will live forever. But if we set this to something very small, so maybe 0.1 second, it will be destroyed after 0.1 second. And this way, this function here is re-triggered every single tick if the laser is on the actual mesh, but once it leaves the mesh, the outline just dies. So you would only see the outline as long as you hover over the actual mesh. And let's try it out. So no outline, there's the outline, and it's disappearing again. But I'm not sure if you can see it. It's flickering. And the reason for that is, once this outer sphere is actually spawned, the laser is not touching the original sphere. And so the outline dies, but then it's spawned again. So what we need to do is, we need to disable the actual collision of the outer sphere, because we don't want it to block the collision with the original sphere. So let's go in there. And after we set the outline, we want to set its collision. Set actor enable collision to false. And then continue. So this should work now. Let's try it out. And you can see I have immediate feedback. There's no outline, and as soon as I hover over the mesh, the outline is appearing the way I want it to be. And there's also no flickering anymore. And we have a basic outline implemented. So let's delete this here. And now we can go in there and actually maybe we add some variables in there. So what I want to do is to change the actual color of the outline effect. So I don't want to have a static material. Let's create a dynamic one. Create dynamic material instance. And the parameter here you can see it's named color, and I want to change this parameter in there. So I'm going back in here, I write color in there, and for the source material I select my outline master. Oh, sorry. Of course, this don't need to go in there. You can just leave this field blank, but I want to set the vector parameter. And here comes the name color. And for this, I just want to create a variable. So let's call it let's name it highlight color and also expose this. Hit compile. And for a default color, let's give it a bluish and hit compile. And now I can go in there and let's duplicate this mesh. If I select my highlight component on the actual mesh, you can see now I have this highlight color and I can change it to something different, maybe something like this and something like this. And now if I play, you can see that I'm using the same functionality, but I have different outline colors. You can also go in there and, for example, change the thickness in here. So we could copy this, go back in there and also set the scalar parameter value. The name is thickness, and let's also create a variable. Let's give it a default value of 1. And also expose it. And now I can go in there and say, this has a thickness of 1, this has a thickness of 2, and this has a thickness of 3. So let's try it out. 1, 2, 3. So of course you can go in there and change, create your very own logic for this. Also, this is a very basic implementation, because what we're going to do is every frame, if we hover over the mesh, a duplicate will be created, it will be assigned this material, and then it will be deleted. So this is not the very performant best way to do this. You would want to create a logic that actually tells if the laser is over the mesh, and if not, it kills the outline. So just spawn one outline, and if the laser leaves the mesh, you kill this one outline. But just wanted to give you a basic idea of how this is working. And the nice thing is we can actually add this now to every mesh. So let's find some static meshes in here. And let's add our component to every one of them. So, and if we hit play now, you can see that it is only working for this guy here. So if I hover over it, you can see I have a nice outline effect. But for both of them, it's not working. And you can already see where the problem is. The teleport beam just goes through them, and there's no collision in there. So this is a very easy fix. So I just wanted to show you that for this example, it's important that you have working collisions. So if we open up the player collision, you can see this one has a very basic collision, the other two don't. So let's fix this. Of course, we can just go in there and set this to the collision complexity, to use complex collision as simple. This way we have a mesh collision. And we can also go in there and add a more simple one. So let's add a simplified collision for this. Of course, this is not very beautiful. I would do it different way, but just to show you that the highlight effect is working now, I'm going to add the simple collision here. And now if I'm going to hover over the mesh, you can see the outline is working. And also all of its parameters are working. So if we go in there, for example, for the rock, let's change it up. And let's really increase the thickness of the effect. So this was just a quick tutorial I wanted to share with all of you guys, because I struggled a lot with the outline effect for the Oculus Quest. I tried to get it to work with the post-processing, but it's so expensive and it's really not worth the effort. There may be better ways. If you have any tips or tricks you want to share with us, would be great. We're all in there together and I'm really excited to see what you guys will come up with. So thanks for watching.